just love doing proofs. All right, well, let's prove using segment congruence. All right, we got a picture here. This guy's cutting boards, looks like. He's a carpenter, or I hope he is. He may not be from what I read in this. It says the carpenter cuts a 2x4 board to a desired length. And actually, for our purposes in this, that 2x4 board is KL. He uses this board to cut a second congruent board to the first. That one is MN. Similarly, he uses the second board to cut a third board. We're going to call that PQ, third board, and cuts the third board, uses the third board to cut a fourth board, which is RS. Prove that the last board cut has the same measure as the first. Now, I'm not a carpenter by any stretch, but I think I have heard that you don't want to cut boards like that if you want them to be all the same length. That's besides our problem. We're going to ignore it. But I think what happens is you would always use the one board, say that KL, to cut all the other three. Because if you use boards that you have cut from your pattern, you run the risk of all of a sudden ending up with a board that's too short. I'm just saying, if you know any carpenters, you might ask them. I might be incorrect because, like I say, I am not a carpenter. But from there, we can get some given statements. So we can say that this is given, that segment KL is congruent to MN, segment MN is congruent to segment PQ, and segment PQ is congruent to RS, and then we're asked to prove that board RS equals KL. So let's go through our proofs. So we got our statements, we have our reasons. So if KL, segment KL, is congruent to segment MN, and MN is congruent to PQ, and that's part of our given statement, then KL is congruent to PQ. Now remember, in some of our properties like associative, symmetric, reflective, transitive, if A equals B and B equals C, then A must also equal C. And that was called the transitive property. In this case, we're talking about congruence. So we can make this statement that if KL is congruent to MN and MN is congruent to PQ, then KL is congruent to PQ using the transitive property of congruence. Then, if PQ is congruent to RS, which was also part of our given statement, then KL is congruent to RS. So in other words, if KL is congruent to PQ and PQ is congruent to RS, then KL is congruent to RS. If A is congruent to B and B is congruent to C, then A must be congruent to C. And once again, what's our reason for that? The transitive property of congruence. And what were we asked to prove? We were asked to prove that RS is equal to KL. We're getting pretty close. So then we can say that RS is congruent to KL. And what do we use there? We just flip that around. If A equals B, then B equals A. That's the symmetric property of congruence. And then, therefore, RS is equal to KL. I think that's what we were supposed to prove. And what property would we use there? What did we go from? We went from a congruency statement to an equality statement. What's that going to be? Anyone? 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 It's the definition of congruence. All right, well, Shazam. There we go. Using properties. Deductive reasoning. Deductive reasoning uses rules, definitions, facts, postulates, properties, theorems for proof.